Okay, so we talked about the standard deviation as a measure of spread of data for these three data sets, where we have one that's spread linearly, one that's clustered in the middle, and one that's sort of spread towards the ends. But there are other ways to describe this data. Okay, the 5-number summary is a very quick way, especially by hand, to describe a data set. All right, and this leads to illustrating it very nicely with a box and whisker plot. All right, so if I have a set of data, I may be very interested, obviously where the middle is, but we know that finding the average of a large set of data can be a bit tedious, but finding the median is quicker, right? So we can see for this data set, the middle two numbers are 3 and 4, therefore the median is 3.5. Okay, so that's where the median is. So we can actually draw a line between the 3 and the 4 because 1, 2, and 3 are below the median, and then 4, 5, and 6 are above the median. All right. Now the median might be a more useful number sometimes than the average, because if this, I don't know, if these were family sizes and this one happened to have a 12 in it, we would still say that it's most likely that a family has between 3 and 4 members. Just because one family has 12 might skew the average drastically. If for some reason they had 120 kids, the average would go way up, but it wouldn't. The average wouldn't be a good indicator of how big family sizes tend to be. So we wouldn't, I don't know where we would get 120 people in a family, but it would drastically upset the average. Or it would be a large factor in the average, whereas the median would really be unaffected by a large number at one end or a very small number at the other. So we have the median dividing the data set in half. So half of the data is below the median and half is above, right? Then what we might do is we subdivide each half. So this number here is called Q1, the first quartile. And this number here, the 5, is in the middle of the upper half. So that's called the Q3 value because it is the third quartile. The average, you could actually call the second quartile value because 2 quarters are the same as a half, and the median divides the data set in half. So we've divided the data set. We know where the quarter markers are. Now, in this case, we don't have that many numbers. So 1 is in the bottom quarter, 2 is right at the line, 3 is in the upper quarter, 4 is above that in the third quartile, and 6 is in the fourth quartile, and 2, 3.5, and 5 are the dividing marks. All right. Now this lets us draw a diagram, okay, a box and whisker diagram. We can draw a line right at 3.5. I'm going to put it right below my line there. I can draw a Q3 line right here at 5, and I can draw a Q1 line right here at 2, and I can make my box. Then we throw some whiskers on that go from 5 to 6 and 2 down to 1. Okay, so you can see the whisker includes the minimum value all the way to the maximum value. So with the box and whisker plot, we can see where all of the data lies between the extreme ends, but we can see where most of the data lies, all right? So 25% is in each quartile, so in here is where 50% of the data lies, right? In fact, if you went to the college night online, you learn that a school that's pretty safe for you is where your SAT score is in the middle quartile, the middle 2 quartiles. All right, it means you're pretty likely to get in if you fall in that range. If you fall in the upper quartile, so if you're up here, you're extremely likely to get into that school, and your chances are better if you're above the median, but than below the median. But you've got to have a reasonable chance. It means you fall in the middle of the pack for that school. All right. Now we have these numbers in the next data set. They're in order. So where would the median be? The median would be in between the 4 and the 4. So we could say the median is 4. Okay, then we need to find the quartile values for this data set. The middle of the bottom set, there are 3 numbers. So Q1 is the middle of those, and Q2 is the median of the upper half. All right. Now you'll see, while we had to kind of average the middle numbers, we have an even number of data points or members of our data set. So we had to take an average to find the median. And then Q1 and Q2 are going to fall directly on numbers. If you had an odd number of data points, the median would be the middle number, but then Q1 and Q2 would be between 2 numbers. And so you would have to average values to find Q1 and Q2, which would be the medians of those halves. All right, so we can draw this box and whisker. It looks like the median this time is at 4. So the way I drew this, I drew this very badly. I know, because I transferred it down and it didn't line up quite right. So there's the 4. That's where the middle quartile is, okay? And let's see, and then, this is sort of weird. This box and whisker, I'm just gonna make it a little thicker because the 3rd quartile and the 4th and the contains only the number 4. So that's because this is such a small data set. The bottom quartile, the 2nd quartile is there. And then I'd have a short little whisker going out to the 5 and a longer whisker going down to the 1. Okay, so this is sort of an anomaly where only the number 4 exists in the 3rd quartile. So we can't really see the 3rd quartile. But it shows us the range of the data, and that most of the data, 50% of it, is sort of between 3 and 4, which makes sense if we look at this. In fact, more. Between 3 and 4 is definitely half of the data, right? So that's a box and whisker. You can see that's so much faster to do than to calculate a standard deviation, and it gives us a pretty good sense of how the data spreads out. Let's see, what else is there here? Okay, this one. The median is between 3 and 5, so that averages nicely to a 4. So let me come over here. The 4, that's going to be where the median line is. Whereas the Q1 line, the Q1 line is all the way down at 1. So I can draw the 2nd quartile box, and the whisker is non-existent down at that end. And then the 3rd quartile Q3 value is 5. And then we do have a value up to 6, so we can put a whisker up there. All right, so this one is sort of strange because the 2nd quartile overlaps with the 1st quartile, so you can't really see the whisker extending off of this. And it's because we don't have that many numbers in these data sets. So that's how you make a box and whisker diagram. And you can see the one that has the tightest box was also, that would be set 2. The box is pretty compact. It also had the lowest standard deviation, right? So box and whiskers use medians, whereas the standard deviation calculation was aligned with finding the average or mean. So when we, there's different sets of data depending on how you're looking at things. So when you're looking at medians, box and whiskers are good. When you're looking at means, you probably want to talk about standard deviations depending on the way the data looks.